Okay. Yeah. Why is actually so? What happens is you can. You say?
Is it because of the number as is actually a decimal number because it's a float?
Yeah. Yeah. It's a floating number. So I need to use a format specifier for float. So what's the format specifier for float? Who knows?
I think it's F.
Yeah, F now.
Okay. So we can see that we have, let me add a new line here. What is going to happen? I've not tried. Okay. Let me see. Okay. You can see that we have this guy and this guy. So what the macro does is simply replaces a long line of text or number or even a function. We can actually even do a function. We can actually define a function. Let's say this is some x, y, and then the value for some x, y simply does something like x plus y. So let's say this is what it does. All right. So we can actually see somewhere two and three. Let's just print it straightforward instead of assigning it to a variable. Let's say print f. No line. Okay. Yeah. Macros don't have. You don't use a semicolon. You don't need to use a semicolon. You just define them. Just know that how it comes is that when you have the macro name and then you give a space and whatever you write here onward is going to be the value you want to represent with the name. So I had a semicolon there. That's why it gave an error. And also for macro names, it's quite it's good practice to use a capital letter, to use all caps in naming them. It's not like lower cases can't work. They can actually work. It's not case sensitive, but then it's good practice to use upper cases. So for ease of readability, so someone can just go through your code and see something like this, and then he's kind of informed that, oh, this is going to be a macro, than just having it in small cases. And you can have your macro in lowercase, let me say name, and then someone comes again and define a variable name as name. So for example, let's say char name again. So that will be conflicting. So that's why it's good to always use uppercase. So let's run this now and see if we are going to print the sum of 2 and 3. And we can see that we have 5. So it means that the use of macro can be almost limitless. You can also use it for functions. So let's say we have a function that, what should our function do now? Let's say we have a function print, right? Let's say the function name is print. And then what is going to be our function definition? Our function definition is simply going to be something like printf.
So Franklin,
Yeah,
let's prepare. All you from what if I get it correctly, all you are telling us is for the macro, whatever whatever comments that comes after whatever you state. Let's say, let me put it this way. Let's say for the statement you give and the instructions you come with. Once you call that statement or you call
yes,
the macro, it's going to execute exactly what you ask it to do. Or just call it will call the content, right? Let's say I give
yes,
for the macro, let's say for the name put function. Okay, let me even use the sum. The portion you use
mhm,
the sum. Perhaps you change the last comment to x times z, and I call print sum. I mean, it's going to make sure that it multiply whatever that is within that comment for me, right?
yes. What
Okay.
it does, yeah, that's what it does. So I've not actually tried this, but I'm just trying to follow the concept of this macro. Let me see what is going to happen. So because what macro does, like I said, is going to represent whatever I put here by the name here. So let me just see if I put just print here and let me say semicolon. Let me see what happens. And it actually printed hello, right? Let me put a new line here. So you can see. So if I didn't put my semicolon here, it's, it's going to have an issue. There's no semicolon. So what macro does is it copies, simple, copy what you have here, paste it in your code. That's the processor is doing that too. Paste it wherever you have that name. And so because we have this, I just have to put this guy and boom, and then we have the hello here. So, but then it's advisable not to use macros as for function definition. You can, like I said, you can replace, have a name like that. Maybe you have one long function like that. You just define the function and just use a name for it. So wherever I just call that name, it's just replicates the function there, not executing the function. Where you call the name, it doesn't execute. What it does is simply copying the content of whatever you've done, the value here, and pasting it there. That kind of thing. That's what the preprocessor does. So it's not advisable to do that because of a particular reason. So let me show you. So let's say we have something like this. We've defined something like this where this is our x, this is our y, and let's say we have something like x plus y, right, plus y times, let's say x plus y times y, right? That is what this is going to evaluate to, x plus y times y. So let's say we have, for example, we do something like, yeah, we still execute our print sum this. What is going to be the answer? Who has idea? What's going to be the answer? Can someone just tell us from what you've done? What's going to be the result of this?
15.
Um,
It's not 2 plus 3 is 5. So 5 times 3 is 15.
okay. Any other answer? Any other answer different from what um, we have?
No. So 9. And also that the y times y first before the addition is going to give you numbers 2. It's going to be
Hmm?
11,
Okay.
which I doubt greatly it will do. Let me see,
Mm.
board one. So multiplication,
Actually, that's
addition,
what
so
it's
yes,
going to do. It's going
it
to
will do
follow
the
the board master.
multiplication. Yes, board one.
Yeah. Okay. Let me comment out, print out. We are not. So we have 11. But now there might be a case where we have something like let's say I'm trying to figure out the case where this is not going to give us what we want. Yeah, let's say x plus y. So what do you think this is going to give us? What this is going to do is actually going to multiply this, and then whatever value you get is now going to add it, this plus this, and this plus this. So from here, I think it should be 2 plus 3, that's, sorry, 3 times 2, 6. 6 plus 2, that's 8. 8 plus 8, 9, 10, 11. 11 too. So we have 11. Oh, so you really have to be careful, when you are trying to use this so that you don't get into trouble. You have to be very, very careful. So that's why most times they don't use it for maybe to define functions. Because you have to be careful. There is a little mistake you make can give you a different result. You can see now that we are having like 2 plus 3, which is 5 here, and 5 here. 5 times 5, 25. So a little mistake can change a whole lot. If you have something like this is also different. It's going to sum 5 and then multiply with y before it does this. And we have 17. So I think basically that's it. So, and also, like I was saying, we have some other macros. What do they call it? Let me see. They call them I'm trying to remember what they call this, all these keywords which we use. So, but then there are other ones like we've seen the define, you've seen the if not define. You've seen end if. So there are other ones too. Like, let me clear my screen, and there are other ones too. Like we've seen if not define. We've seen this. We've seen define. You know what this does. You know what this one does. This one is like saying if not define. That's what it means. Like asking a question. Then this one says define. So it's like an if statement, and they'll have like a plain if statement too, like if right, and they have also else, and they have else if. and we have end if. So I wonder why this one is not so you can simply outline like a code with these things, like you know what define is, and we have undefined. So we have undefined. So you can define something and then undefine it later on. So for example, um that is the order of everything. So but what happens is we have our else. You can say if this is this. For example, you can say if which is for conditional statements. If let's say s is equal to s, you can say you should do something, right? Else do another thing. Else let's see. I can't really remember the syntax, but I think this is what it looks like. Or from the markings is showing me as if it's not it. Let me see the notes. I can't see it in this resource. Identify value. So optional system. We know what's going to happen here. So it's not going to do this plus this, it's going to do this times this before this. Okay. Yeah, we can see where it's being used, the if and. So okay. Okay. So let's see. So we want to um, we want to define this and have name print this if we have like one. So let me see if this is actually going to work. Include and let's say we have our main. And we are returning 0. Now we have our name here. Let's run and see what happens. Implicit. Oh, it's printing. So what's actually happening here is I'm going to put this in between the main function. So instead of having it here, because if I have it here and our function is executing, for example, we are saying like if like the script below is false, which is if it's 1 or something, it should print this, which is actually going to print Frank, or which is actually going to replace this with this. But then if what we have is 0, it is not going to print. So, and when it doesn't print, it's just going to be seeing this name, so which is going to make our code break, which is what we have here. So let me try and put this in between. So you see that it's not printing because our if statement is evaluating to false. So if 0, false. If 1, which is if it's true. And it's not working. Okay, let's try again. Right? So let's see. But there might be a problem. I might have to review this thing again, guys. I might have to review it again. But basically, that's the most important thing, the syntax, understand the syntax. If you are defining, you have the identifier name and then the value. And wherever you use it, what is happening is it's actually just going to replace the name, the identifier name, with the value. And also you understand that to use this as to define functions is very risky and can cause error and it's not advisable. So most times what we use it for is maybe some constants and the rest of them. So and maybe simple things like this one we can do. So you can still use them to define complex things like this is a function, the swap. And what this is doing is simply swapping A and B, right? I guess. So same thing here. You can see we are also defining another function max that accepts two parameters A and B, and the definition of that max is this. It's going to check if A is less than B. If A is less than B, it's going to return B. Else it's going to return A. So yeah, that's what this is. And also you can, instead of defining things in a straight line, we can also break them like into different lines. For example, we could have had this curly bracket with A caret equal to B colon, have them just in one line. But you can break everything in separate lines by just pressing your enter key and putting your slash, and you still have the same thing as this. So basically that's it. This is another one, and this is the definition. So now they have some macros that are like they call them, I think, system macros or so. This one's like your standard predefined macros here, like this. So what these macros do is that they are already defined, by the system. And what they do is actually they have a definition already. This macro is actually going to print your file name, or it has your file name already, or the file extension. Why this one has not the file extension, the file name, or the path, the file path. This macro expands to the name of your current input file. So that's what this does. Why this one is to the particular line of code where it's being called from or where it's being written. And they have other ones like dates, they have time, and they have this one. This one is going to, I think, print one if our program or our C program supports the ANSI standard. So all these things are identified, but then these ones now you don't need to define them; they are predefined in the system. So let's see how this one works. I'm just going to review this thing again, but the concept behind this if and else and if else and the rest of them is simple. If let me say a condition you give here is true, it's now going to talk about define. Just the way we have if not defined main.h, define main.h, and then we'll end our if statement. So that's how we have these things too. So they are like just conditionals. So but let's look at the predefined macros. So like I said, let me print the name of this file. Is it going to work? Because I don't know how this what's the name of this thing we are doing, the name of the file? I don't know. So let's see. It's actually not printing. Or if because this platform we are using is an online platform. So normally it's supposed to print something. Well, if I should do that on my system. Let me see.
Frankie, do you have code blocks?
No.
Or you this is Visual Studio?
Yeah, I use Visual Studio.
Do you have this one, please? I'll start you this. I want you to send something. Because I'm trying to use the Visual Studio. My MWing 64. I can't install it. When I download it, it just gives me an empty folder, nothing to install and copy from there.
Oh, okay. Maybe we'll talk about that one later now. Okay, it's actually printing it, not is it? It's not. So, but what this is supposed to do is print our file name. Let me try replicate to do something.
Hello, Frank.
Yeah.
I thought we were actually solving the project here because we have two projects. I thought we were actually solving it. Not even two, three, because you need to go and read to prepare for your partner or the other for Sunday's project. I thought we were actually solving today's projects.
Oh, we are not solving them.
I know that we are trying to get this concept, but we can actually do that later.
So you can see it prints. This actually prints the name of the file, and if we say date is actually going to print today's date. So that's how it works. So you can see most of the system, the predefined macros. You can see them in one of the resource we have. Okay. So one more thing before we check for those that are stuck maybe in any of the tasks is if we have like a macro like this, let's say define, and let's say the macro name is, let's say name, let's be using the name as we've been using, and then the value we want to use is let's say mark is the value, and then this mark also is actually a macro. Now when we print name, what do you think is going to happen? Or when we call name in our code, what do you think is going to happen? Does anyone have an idea?
I think it will print good.
Why?
Because okay, well the first name has mark.
Mm-hmm.
Are you getting it? Now,
Mm-hmm.
and the same mark is
Mm-hmm.
also a name, another mark which has good. So it's
Yeah.
I think it's either it's going to bring you both mark and good, or it will choose from it because there are two. Are you getting it?
Mm-hmm. Mm-hmm.
And
Okay.
it's more or less like a macro has two different entities.
Okay. I think that's it. You got it. You got it right. So what happens is if we say Mark and we want to print, remember what it's going to do is just going to say, oh, this is Mark. It's going to pick this guy and put it here. And when we try to print, it's going to print good, right? And if we use this guy name, it's going to check, okay, what's the name for value for name? Value for name is Mark. And Mark is also another macro. So it's still going to go down further again to go and look for what it is and also give us
Please,
good again.
please, can you zoom your screen? I can't see, it's too tiny.
Hope it's visible now.
Yes.
Okay. So that's what's happened. So that's what happens when we do something like this. So actually it's going to call Mark and Mark is going to um, get this good and do the replacing that it does. So what this tells you is that you can actually use this for an infinite loop. You know, when you are writing a function, you can use it and also have an infinite loop or a function that calls itself. You can have name call name or name plus. You can have something like name plus one or something like that. So whatever is just for you to know that you can actually use this to call itself and call itself in it. And this is going to go and call this guy, which will call this guy plus this guy. And depending on what you do, you can get into an infinite loop or get into the right loop you want to do, loop or the right way you want to loop things. So that's I think basically that's it for it with what I've explained. So I think I'll be able to solve the task for today. So is anyone stuck with any of the tasks for preprocessor? Is anyone stuck with it? If you're stuck with anyone, just let me know. So we focus on that one before we try solving each of them. If not, we'll just get into solving each of them.
The first week of them, I'm not sure anybody has started later because we are very ask the quick question. Let's say.
Yeah, I can't hear you clearly.
I'm not sure if anybody has started and gotten started because like all of us have not started. Even me, I've not even answered the quiz question for that.
Okay, so let's start with the first question here. So they said we should create a header file that defines a macro named size as an abbreviation for the token this. So size should be an abbreviation for this, so you know what they want you to do then. So what you are simply going to do is, what they want us to do is create a macro, right? So let me create that macro. What we are going to do is create a macro, and the name of it's a header file. You know, they say create a header file that defines a macro. Name this. So we are creating a header file, and this is the name of the header file here. And what it does is it defines a macro. So this is our header file. So who can remember how we define macros? Who can remember we said hash. Let me minimize this. Define. And what we want is size. And then the value which they call the abbreviation here is 102 4. So basically this is it. But then naturally, when we have our .h files, we are going to be including them in so many other files. So it's always good, or it's good practice to ensure that you make sure that you put your guard. They call these things guard. That's so that you code the preprocessor don't repeat codes. Copying one my .h files, a main file, and compiling them at once. So that's where we use this if not defined. If not defined, the name of our file is what? Object underscore like underscore macro. So object like macro.h. So that's why I'm saying object underscore macro. So if not defined, then you say define object like macro.h. And as usual, you need to end your if statement. End if. So what these 3 lines is like the conditionals. So wherever we are going to be attaching or importing or including our object like macro.h, the header file. So it's first, before it goes to define any of these things, it's going to check, is it defined anywhere? If not, define it. Okay. So that's it. So basically, if you do this and push your code, you should have your answer that you should go through. You have to run Betty too. So the task 1 says create a header file that defines a macro named pi. So it's the same thing, just we are going to have pi here as our macro with this value. Pi is going to have this token or this value. So I'm just going to copy it and put and paste here. And I'm just simply going to label this the right name. I'm just going to say pi. That's called h. Pi h. So for this, you are good to go for that particular task. So simply defining pi as this, and then you push your code. So it's going to check whatever is like I said, if we have like 2 headers being included, it's going to check if it's defined already before it defines this. Next one is say write a program that prints the name of the file it was compiled from. So we want to know if we're compiling something, you want it to print the name of the file it's compiled from. So to write that program, it's going to be like a C code. You can see that the name of our file is tomain.c. So, and I think we've done that one already. I think we did it somewhere here. Okay, we wiped everything. And that was the first thing we did here. Okay. So you can actually do that. Like that's is a predefined macro already. So it's a string. The name of your file is going to be a BA string. So that's why we are using the string like format specifier. So, and this is the macro that specifies the name of your file. And you can see that we have main.c here. So if I change the name of our file, is it going to compile? can see is smain.c. Now, what's this? So basically, that's what this is supposed to give to you, like just name of a file. But let me so that's just name of a file. And this one is like writing a function, write a function like macro. So this is a function like macro ABS that accepts like a parameter x, and what it does, it computes the absolute value of x. So how do we do it? So write down macro. It's going to be on a file. So let's create a file. So normally we say if not defined. And if so, let's define our so what this is, what it computes is the absolute value of s. So which means s can be negative, can be positive, whatever value of x is, what we want is the absolute, which is an x that is always going to be positive. So how do we compute that? We can actually use the what do they call this thing again? I've forgotten the name. Here you can represent something in a line of code. So let's say if x is less than 0, right? So we just print minus x, which is simply like multiplying x by minus 1. Else, we just have our x. Who can remember what they call this kind of representation of code? What do they call it? Can anyone remember? Am I the only one here?
Go talk now. Another compiler, where is he? Has Oko left us?
I can't hear you.
I was calling out Oko to answer. He knows those terminologies of it, and he's also not here, has left.
You want stressful code? So that's it, right? After that's it for
Franklin,
this.
please run it. Let me see something. Please run it for me to see. I beg.
If you want to run this, it's not actually, unless I'm going to like test it with, okay, let me test it with the test file. Let me call this 3 main.c. Okay.
Good evening, Mr. Frank.
Yeah, good evening.
Sorry, I wanted to ask something from this particular code writing.
Yeah.
Yeah, why? I'm just curious. Actually, it's not like maybe,
Mm-hmm.
but like why is it that when you wrote x is less than 0, and then the question mark, then you wrote
Mm-hmm.
negative x, then
Mm-hmm.
colon, and then x. So like, couldn't you have written negative x should be equal to x, like equal to, or using if else statements?
Oh, you can actually use if else statements.
Statements. If you just make the
Yeah,
code
but
longer.
yeah, it's just going to make the code longer.
Okay.
It's just going to, it's not, but it doesn't mean that if else statement it will, but it's just going to make it
Yeah.
longer. I forgot what they
This one
call
is
this
just.
this code.
Yeah, I'm trying to remember it as well. Is that not absolute value?
Like it starts, yeah,
Is that not absolute value?
absolute.
Which code are you talking about?
This one. But this shorthand representation, that's what I'm trying to remember what they call it.
Ternary operator. I just remembered.
Thank you. God bless you. Yeah, that's it. Scenario operator.
Didn't I say it? Didn't I say it?
You said it. I said it. I was
You
deaf
didn't say
then.
anything. You didn't say anything.
I was
I
they
said
fenced my ear.
the compiler. I was looking for you. Ask everybody that was on. I said you're the only person that will give us the name of this thing. And you
Is
came.
it?
You didn't put it on. You think I don't know you?
I'm
My
not
brother is a
hearing
compiler.
you. You
I
said
said
what?
I told Franklin you are the only person that can answer the terminology he needs, and you were off. Immediately you came online. You came to answer it. I'm a
No, not
prophet,
me
so I'm going to
answer.
open a church.
Nah, Abdul.
In prophets don't fail.
Okay, he thought you answered it. It's Abdul that. Oh my god.
Prophet Ghost that I've cast.
Prophet
But
Ghost indeed.
this one, I both team to score over 25. Both team to play over 2.5 no cap.
So you can see the output of the file is the same thing with this. Although where you get the same thing with Chaka, it does not mean that you've won. Well, actually you've won for this one.
So Franklin, once you
Yeah.
write the code that's showing up there, up where the end, where the end is, I leave you to run, right?
Yeah, it's true.
Okay.
Yeah, I believe putting this x and all these variables inside brackets independently is kind of part of Betty style.
No, it's not Betty style. The reason why we are doing this is because of, like I said before, you just have to be careful with how you define some some macros.
Variables.
If you don't have,
Yeah,
if
macros.
you don't have them in brackets, sometimes it might mean something. It might turn out to be expand to be something else that you don't want. Like when we did
Yeah.
something before, we did the plus and minus. We wrote a function and did some plus and minus as the function definition, that kind of thing.
Yeah.
And when we put our values, it was giving us something else when it was in board mass and the rest of them. So that's why most times it's better you just put them in brackets so that it's just going to know that, hey, this is what you're working with. So it's just advisable to
Okay.
always put them in brackets.
Okay. I think I get
Franklin,
it.
Yeah,
Franklin, what if
yeah.
I state the macro functions, and I put the code that was given by ALX over it? Like, will I set the desired output? Like, for instance, I just list the macros, and I just
Hmm.
can just write the code int main voice, the int s. Okay, let me say I use a is equal to sum of 98, comma
It won't
1020.
work now.
Then I print.
Check out, go and check what you're doing now. You're not doing what they ask you to do.
Okay.
Mm. Like if I got you right, you mean if you just do like let's say you just write a normal, a regular function for example here sum, and then you try to print the sum.
Exactly.
Though it's
Yes.
not going to work. It's not going to work because checker is going to check for some things. It's going to check if you have something like this, if you have something like this, if you have your main.h files, and I don't think you can define your function in a .h file like you have here. It has to be a .c file that will compile. So what checker does is going to try to use the file you've provided to process this other three .main.c. So when you use this and then you put your C code in this, it's not going to work.
Yes, but when I want to teach that way, you look at this side. What if I create a .h file that I've already listed the macros in it? So like let's say I did a define function like underscore macro and list all the other macros that I have to state in it and save it already in it before compiling. What of that one? The checker locate. Do you see where I'm
Uh,
coming from?
yeah, I get where you're coming from. Just the way we have our previous .h files, like main.h files, where we are putting in
Sure.
prototype. It's going to compile, but like I said, it's just going to work for this particular um, project because this is where you're going to use it. Unless you want to go and change the name of the file, and push it again, which is going to be like a second file or something. Because when your what do you call it, your checker is checking, it's going to check with the name of the file. So if I get
Oh,
you rightly, maybe you want to do this, and maybe the solution, just define it here. And then for this second one, because here we also have to write like a function like macro, so you can also say define again.
okay.
You can also say define, but then what you need to do is look at the file name. This is what the checker will be looking for. So it's
Okay.
just better you create a new file. Yeah. So, but for that one, I think we just do it sum x y, and what they wanted to do is compute the sum of numbers s and y. So you can just say x plus y. So you can just have your own s without the brackets. That's why I mean it's just simple mathematics, so it's not too complex. But I just put them in brackets. Or in my actual code, I didn't put them in brackets, but I just put them in bracket here. So this is the answer for the last one without this guy. Let me take this guy out. This one is for number, the previous one, and then this for the next.
Oh,
So and if
okay.
we should, test it to see that so let me compile it. Include force on dot h. Okay. Yeah, I need to rename this guy now. Okay.
Like function macro 8, you know some?
Hmm?
The name over there. It's a function like macro 8. So, on a square.
You can see that it's giving us the sum of these two, which is the same as this. So that's it for this project. So any question before we move over to the other one, the other project? So, and has anyone done that project? Because I've done it too. So I'm just going to, which is structure and typedef. Has anyone done it? Are we still here?
Yeah, we are. Just that I guess no one has done it yet. I've not done it as well too.
Okay.
If I'm still trying to check all my answers for the quiz.
Okay. Okay. I've not done the quiz too. Let me see if I can do the quiz. But let me just see if I can do the quiz. If I can't do it, it means a while a day.
No, it's not something too complex. I've I've worked on it too as well. It's not very, very complex like that.
Okay.
Just if you don't comprehensively read the resources, you might have a hard time,
I've
just
not
like I
I've not
have.
I've not I've not read the resources or the resource. The general syntax for structure declaration, struct stagnant. Number two. Yeah, true. Do they put a comment here?
Go watch and take alongside. I beg you.
This is x1, y2, 2 x1, 2. 2. Two. Okay, let's go there. So I'll just explain the what I know about struct before we continue. So we know that in C we have variable type, we have int, we have char, we have. Do you have any other one apart from int and char?
Yeah, I think we have double, we have float.
Yeah, we
Which
have
one?
double. We have float. Any other one? So the struct is not a data type, but I see it as a way of organizing our data. Just the way we have array. What array does is that it organizes our data, so that we can easily retrieve them or edit them or manipulate them. Structure is also like that too. So, for example, we need a collection of data of different types, and we want them organized maybe just in one particular location. We can use the struct to do that. So, for example,
Sorry, please come again, I beg.
like if we want to, we have array. Our array helps us to manipulate files or something like that. Like it helps us to have like different number of files in one particular location or one particular um, set of memories that we can just easily access them. We can easily manipulate them. So we can have like an array like this, an integer array, 3, 4, or we can have a character array too. Let's call this one name, right? You can have even a 2D array and the rest of them. So what they just help us do is to what array helps us do is to organize data or access the data smoothly, just as we want to. Something like this, or even a string. You understand? Let's see. Yeah.
Fine. Oh.
So, but there's something called struct. So, what's this kind of I don't know what to call it. I've not read through the resource, but what it does is it helps us create a kind of structure where we can be that can enable us also manipulate or access data. Just the way we have our array, and then we can say for example, here we can say ARR0. We know what our ARR0 is actually equal to 0 from what we define here. And we have that our array at index 1, we know what it is. It is 1. You can see it here. Array at index 2 is 2. Array at index 3 is 5. So it's the same thing with this one too, the same thing. You can say that name, the array name at index 0 and 1. I hope it's what I'm saying is actually true, but I think it's B. That's what it is. It's a character B. And at index 0, it's 0, 0, not 0, 1. 0, 0 is B, 0, 1, 0, 1 is, this is a 2D array. Let me just print this thing and I see. Let me just print them and see what I'm showing. What we're going to have print f um, so I'm just going to jump straight to 3. So I'm just jump straight, so we'll print 5. Okay. without a cast. And okay, so you can see that so pointers you can I said yeah no arrays with array we can simply manipulate data, access data in an organized way, you know, than having to say int x equal to 0, int I equal to 1, int, and then for whenever we want 0, we'll start calling int x, and whenever we want 1, we'll start calling int I. But we can just say, and int x and int y can be in different memories that are unrelated. Or with an array, this memory are just going to be kind of progressive. The memory is storing these values, and we don't need to have like different names, for different names for each of these for their memory location. So we can just use the array and then use this arithmetic to look through each of the values. So what array helps us do is like organize our data, access them, and easily manipulate them. So struct is something like that too. So, but for structs now, we can have array. You need to have in an array you have data of similar type. In our array, you cannot have in one array one data is string, another data is integer. All of them must be of the same type. But in structs, you can data of different types all in one place, and you can easily manipulate them and work on them. So I think we'll understand better because that's what coding does. You understand when you write your code. So for you to create like a data structure or struct, you have to start with the keyword struct and then give it a name, give the struct a name. Most times you start with with uppercase letters. So let's say, let's call this, what do I call it now? Okay, let's say week, right? So let's just be days of the week, and yeah, let's define, or okay, let's say day, day equal to, we'll call this char day is equal to today is Monday, right? Monday int, let's say time. So time is a keyword. Let's say let's say team. Let's say team for time, but actually it's time. So currently is, let's say 10 because it's an integer. So let's not go with float. So what is actually going to happen is this is now a structure. What is a structure does? Oh, I'm messing it up. What a structure does is like a kind of template that we can assign to a kind of variable. So for example, normally I just define these guys now, like I said, char day, I said Monday equal to Monday, and in time I give it a time. So, but a structure is just going to be like a kind of format we can always call on to use it and reuse it. For example, you can have something like, let's say, struct. I'm going to call our structure, which we've called already week. And then I'm going to pass this structure that we've defined, pass it to another name. I don't know, but in JavaScript, they call it structure is the same thing like object or class. If you have idea of JavaScript, it's just like class. So doing this now, what this actually does is that it's going to carry like these templates we've defined for this week and give it to this P. So it means that this P now, if we should look at what this P is bearing or what kind of structure it has, it's going to be something like this. And we can also change each of the value of P, just the way we have here. So we can assign new value, just the way we have our arrays, and we say array 0, is equal to 1. If we want to assign or put values for an array that we didn't define the size, we just said int arr, and we did something like we just declared it. You can say array 0 is this, or we just say, yeah, you can just declare something like this. You can say array 0 is this. Let me comment this guy. So array, the value at index 1, and give it a let's say 4, and the rest of it. So this is how this also works, kind of. It's just a similar concept, not exactly the same thing. So when you first of all you create your structure, I'm calling this a template. So you know that this is what the structure looks like. Now you can simply just assign that template. Which template struct week? I need this template to be assigned to let me call this an identifier P. So if I want to now assign values to whatever that I have here, I just say p.day equals to, now I had Monday before, right? I can say Monday, and p.theme, I can say 10, right? So I can go ahead and still print these values. What is p.day? We are expecting to have a string. So t.theme. So segmentation fault. Wow, nice. Why do we have segmentation fault? String.h. Okay. And same thing. Is the structure defined outside? Okay. Okay. Are we still here?
Yeah.
Okay. So this is what the structure or the concept of the structure looks like. So you are going to define a structure for your data. So your structure can have whatever kind of data type you want within it. You can have char, you can have int, you can have an array, you can have a function even within the structure and the rest of them. And then you can always reuse that particular structure. For example, we have labeled, we have used this structure and kind of appended it to, um, let me say, a name, P. And for us to access the day, uh, identifier here, or the array, or what the character array here, you can say p.day and we can access it. And then we can then put the value we want to put, which is a string. And for us to be able to, we cannot just put like and cp.day equal to Monday. What we can actually do is to copy this character into the memory or where this guy is. That's why we said we use the string copy to copy it actually into this. And then p dot time, we assign the value of 10 to it. So when we try to print now, what is p dot day? You see that p dot day is Monday. And when we try to print p dot time, you see that p dot time is 10. So that's what the structure looks like. So we can have like I said, you can have it like however you want it to be. So I just did a quick Googling. You can see some like this kind of example. We include our stdio because we're going to be using print f. and then the string.h because we're going to be using the string copy function, which is the STRE function. You can see that we have like a struct called, we created a struct called student with some definitions or initializations. We have a long int, roll number. We have an int, the age of the students. We have a char, which is name, which will store the name of the student, and then an int that will store the total marks. We can even still have an array in structure. Now we can see now that this is being used on an like on an identifier S1. So what this is going to do is kind of copy this kind of template to this name S1 so that we can simply get access. Like S1 is now going to have this structure of data in it. So now we can now begin to, impute the values for S1. Now it's not going to be copying it to the struct, but rather to a structure of S1. So S1 dot row number. So for S1, it's going to have a structure like this, and for row number, it's going to give it a value of this here. And for age, it's going to give it a value of 10, and for the character, it's going to give it a string of Jonathan. And char S, let me see. Char name. Okay, yeah. Okay, it's actually copying the string from S. So you copy the string to S1.name. So that's how we can put these strings, like, put strings. We have to use the string copy for strings, and then the total mark this. And the normal way we did our printing, you can print the value of whatever you want to print. Like you can see S1.row number, S1.name, S1.total mark, and they printed the row number, the first row number, name, it's this, total mark, this.
So Franklin,
this is printed in one line. Yeah.
So if I get you right now, so Per, what you are explaining with what we have now, that means after using our include studio and the include string, the next thing we'll do is, the struct. In our case, to solve this project that we have, we're going to use struct dog, character name. Then let's say int age.
Which of the tasks?
The tag 0, which is the first one. The
okay.
Puppy. So we are going to use struct name. Then we use the struct dog, sorry.
Yeah.
The struct dog, character name. Let me say int age. Then
yeah,
okay, so character. So we should use float.
Yeah, that's what is written here, float.
So float age, right? Then character owner. Then after we are done with that, then that is where we can, like you said earlier, where we assign the struct. So the struct dog can be assigned to, let me say, I choose to assign it to, let's say B. So struct dog P with my, I don't know, a semicolon or whatever it's called. Then I will now come and start calling whatever it is. So for wherever I've given the character name, and like you did in your example, stripper, then I just include okay, so the B, okay, fine. Okay, Monday. Then I called it before the print out. Okay. So whatever I'm assigning the struct dog to is what I'll make use of, right? So if I assign it to K, I'm going to use K.
Yeah, exactly.
Franklin.
Yeah.
Yeah.
This concerning this task 0 that Nathan is talking about, the
Mm-hmm.
file they are supposed to create is a header file.
Mm-hmm.
So I don't understand. Are we going to be doing macro defining, or how are we going, like?
I think we'll just solve. Let's try and do that one now and see what happens. Let's see. I'm not
If
done it
it's
soon.
C, if it's dot C,
Mm.
well, I don't just understand. That dot H is.
So they said define a new type struct dog with the following elements: name, this. Okay. There's going to be our header file. So remember what when you include a file, what it does is simply is going to go to that file you've created and just copy whatever that is there and paste it somewhere. So for example, here we can see that they are including our dog.h file. What the preprocessor is going to do is it's going to look for dog.h file in the current directory and copy whatever code is there and paste it here. So forget about this dot, just know what it's doing. It's going to go and copy. So even if you have your C files, just the way we have our prototype, those prototype are actually C codes. They're C files. They're not like a. So what it does is it's just going to copy those prototypes and paste them here. That's what the preprocessor does. And paste them at the place where we have our header, so that once the compiler is compiling, it's not going to tell us what error will it give to you? Undefined or right undefined or undeclared. Just telling you that your function was not defined or it was not declared. You just wrote your function. So which means you can write your whatever in this dog.h file. You can write your C code there. So but since it's a header file, we have to use our if not defined. So they said what define a new type. So struct dog. So they want us to use a small d, and we don't use a small d. So okay, that's it. So we've defined the structure. That's what they want us to define. They want us to define with the element's name, and the name is going to have this type pointer to character and age is going to have float, and same with owner, letter to character. So I just did going to git add, git commit, and git push. I didn't even use Betty, but oh, no description for. Oh. So we have to give description, open brace position. Oh, sorry, Betty. I'm very, very sorry. I hear you, I hear you, I hear you. So we have to like describe what our structure is doing. We say this is for, what is this one doing now? Dog properties. Name, age, age. I mean credentials. I call them dog credentials. How would it be now?
Yeah, that's going to keep no.
Well, I bet it's still saying that no description for dog. How does Betty want me to describe?
Oh, Mr. Franklin, I think you are going to like do the description like you always do in a normal code.
Uh,
But the thing is, this is not a normal file. This one is .h file.
your no, your .h file is a file. Okay, see, how do I explain it now? If you
It's a
have,
header file now, Abi.
yes, what do you think
Okay.
happens when you are processing your header files, like your main file, like where you have your main function, your C
It
file,
will
your
go
source
to the
code?
header file to pick things from there.
Yes, and paste it just exactly where they are. So even if you are writing this thing here now, once we are compiling, by the time we are compiling, this thing will be in our C file. It's going to be copied from here to our C file. I don't know if you get me.
All right.
So this is just as the same thing I was going to go and write this in your C file. Um, Abdul, am I getting this right? I've not read those materials.
Yeah, just like the normal what's it called? Yeah,
Betty
something like
style.
that. No, it's going to be dog struct, like dog then space struct. Then you use a dash, just like if you want to describe the main function.
Okay.
So then you do a description for each of the parameters, name, age, and owner.
Oh,
But those ones will be with column. No, this one does not. The first one does not need an at. It's just like a function, so you don't need
Okay.
an at. So it's the subsequent ones that you need an at. The name, the age, and the owner. And then
The second one should be
you give it
in the description.
a return value.
It also has a return value.
Yeah, you have to give it a return value. No, not the code, but like in the Betsy documentation.
Mm,
Franklin, did you replace
yeah.
the owner with just the at character at char after the age?
Oh. Thank you. Just decided. Nice. 11:22. I think maybe when we just saw one of the stats, then we might have to call it a day.
My friend, why?
Frank,
Yeah.
I thought that description should be done in it mean.
The description should be what?
That in it main yeah brackets. It's not put. I thought it's for that description.
In it. Which in it?
If you are talking about struts, are we not talking about I believe this one is the user whatever. Then the main one is the struct this. I did not put that mean anything mean or whatever. Who is laughing?
It's Nathan.
So the question says that we should define a new type struct dog with the following credentials. This. Let me see this main. Let me see what's going to happen here. Struct dog, my dog, fine. My dog dot name copy. Function is my name this. My dog dot age.
See the init main void I'm talking about is there. You did not add it. That thing should be talking about description.
Init main void. Where is it?
In this example of Harvard, see it here. Init void. This init main void.
Sorry, Mr.
Yeah.
Franklin, are you still having a problem with checking the code?
Yeah.
Let me see.
Franklin, what Esther is talking about is you see that after the descriptions that was given in the compiled code in the project, when
Okay,
the
Mr. Franklin.
int main void before the struct dog, my dog, where they declare. So I'm certain Esther was telling us to make sure we bring the int main void before we bring our struct dog. Are you getting it?
That might not actually be possible because this file is more or less like a main.h file that contains the function prototypes of all other programs in the project. You get so, but from what I'm seeing in the code now, I think the most likely error is that Mr. Franklin did not put a semicolon, like he did not end that statement, the struct statement after
Okay.
writing it. At the end of the
Okay.
second, yeah, you did not put a semicolon. Yeah,
Okay.
you did not end the statement. So that might have probably been the error. Try it again now.
Come on. See program as a debug code, no be small thing, no.
Oko, behave yourself. Now you be the real compiler.
Yeah, my brother. As everybody did do, and so me I dey look.
Oh, it's on work. Nice. Nice debug.
Hiya! What's the debugger? Don't go there. Cross
So
and
you
die.
don't see the programmers now, be.
Abdul, you're my new best friend. Oh. And they enter your DM straight away.
I dey
Oko,
look up to you, boss.
I beg you. Oko, you cannot drop from my car.
Na your
I
face
cannot
I dey
continue with you
watch,
again.
my boss.
Now who get money? Now who be code? Now here they said. Oh, nice. Abdul, nice work. Franklin done the search for what he do. If not for the burger.
Why when you jam wahala you go sweat now? Why you no go sweat? So second one, it writes a function that initializes a variable of type. Initializes a variable of type struct dog. Okay. While I be like let's go. It's just gonna do again. Okay. A function. Okay, this is going to be the function. It's going to initialize this guy. So dog. Okay, okay. Okay. Normally I would like to, I think maybe whether we'll just end these videos.
Which video will that be the end?
With the record now.
Okay, you record that. Okay, you won't stop the recording.
Mm-hmm.
Okay.
Oga talk say which video they want end.
Oga review.
My
I
Oga.
just want to show. Make I know what it is. So
Oga want know if class the end.
You want sure say these people hope say no be say they won't fly out comot.
I tell you, hope
They won't go sleep. They won't leave out comot. They won't go sleep.
Abi. I think so. I think for now, not just this main.h you need. And let me just close this, save this, and create my main.h file. Mhm. So they carry dog food everywhere.
Nathan,
Bros.
I beg, let me mute that your mic. The notification, the block waiting at the see, I beg. Thank you.
Yeah.
Mr. Franklin, is there a need for a main H file?
Yeah, since we are going to be using prototypes, we need to, when you are going to be using a function, you need to first of all
Yeah,
declare the
the
functions.
yeah, the reason why I asked is that like
So that's why
according
we
to
are
what
using our
I'm seeing,
main.h file.
in this project, is more of like that dog.h is going to be the prototype for the whole
Mm-hmm.
project. So that's why I was asking that. Probably you saw it somewhere that we would be using main H as well.
No. Once you have, normally if you have, it's just like when you have,
Yeah, I get your
like a
points.
variable, like you have to.
Yeah, I get your points.
Mm-hmm.
But like what me I'm trying to ask now is, I think for this directory that we are working on, the
Oh,
main.h
my
file,
network is.
can you hear me?
Mm,
Yeah, the main.h file
mm.
is meant to be this dog.h.
Exactly.
I
That's
don't know if you
I think
I
get
can
I,
hear
me.
you
what
now.
Abdul. Yeah, I think what
I'm
Abdul
not
is
sure if you
saying,
get me.
Franklin.
Dog dot
Okay,
h. Okay. Yeah,
You
yeah.
see, we have
Okay,
a
okay,
dog dot
okay,
H
okay,
header
okay,
file.
okay.
So all the
Yeah, I
things
get
must
you.
be
I get you.
added
I get you.
under
I
it.
get you. I get you.
So I feel under that one, under our dog dot H, you should
I
add the
get you.
distance there.
That's
Okay.
true.
so all the prototypes in that main H is meant to be in
Will
doc
be in the dog dot
H.
H.
Yeah,
Sure, sure, sure.
exactly. You get my point.
So how do I append to dog dot h? Uh,
But are you saying that he's not going to copy the prototype?
Sorry, I didn't get that.
If he's going to write a doc.h, is he not going to copy the prototype?
No, like when it's going to like in the dog.h file, it's just going to add all those prototypes under the structs, like right after the struct
And
function that I just declared.
Franklin,
Uh,
Franklin,
mm-hmm.
to add those prototypes,
Mm-hmm.
like how Abdul is saying it, when you get to the dog dot H, I think the next
just
thing you have to do
Yeah.
is you just do the type def.
open the file and then you
Type
insert
def
it
doc.
like two
I,
lines
I am
after
saying,
I don't.
the
you see, after the description,
open
the
the doc.h file.
why don't we just yeah open the dog.h file and let's do it like additional description or additional function prototypes. We give it that description or additional prototypes or something like that. Then you just put the prototypes underneath it. Or
Please, where are you people getting dot.h and dot like
Doc.h is like the
where?
first project that we're going to do.
That's the first project we did.
Okay.
Uh, well, I was trying to copy, like use,
The content of the main.h, right?
but I don't know if it's going to overwrite it. That's what I don't want to happen.
Okay, I
Just
think
open the file and use your mouse to copy
what
and
you
paste.
could
No, don't pass that level. I know they like that one.
I think what you could
Okay.
do is if you use that CP function, you would use what's this?
Interactive.
Is
Append.
it greater than sign? You use it
It didn't work.
twice. It didn't
It didn't
work.
work. That's
Oh,
for echo.
yeah, yeah.
so frankly, what are you trying
Well,
to
I
do now?
mean,
Tell me.
This copy. Are you sure it's not going to overwrite the one you've done?
only cry will cry, nothing else. Nothing will never see. There is no
Well,
shows.
not true, sure, not true.
No. Let me see. Cat, dog. Google.
I think for this, Mr. Franklin, you later end up writing it with you typing it yourself. Because I was
Hold
trying to
on.
like figure figure it out too.
And no cobbler.
Okay, let's see.
Do not overwrite an existing file. Okay.
Did it work?
I think so. Didn't work.
Yes. Okay, yeah, this is it, Mr. Franklin. I think I just got
Mm.
the idea now. So that was the code. I'm not even sure if you need that if you need that what's it called? That n, but you can still add it. The thing you do is after that dog gauge,
Mm-hmm.
the result you like use that is it greater than less
Type.
than sign? Use it to channel it back inside main H. I don't know if you get me. So it will be three what's it called that will be there now, three arguments that will be in the
So
yeah at
like
the end of that
CP.
yeah main dot h doc dot h, then
Mm.
you channel the results like using that greater than yeah double
Double. Mm-hmm.
yeah
To
and then back into main dot h
back into main.h. So it's going to copy, but what we want is
sorry,
in
where are
doc.h.
you where is you are copying into doc dot h, right?
Mm-hmm.
Uh, then is it not meant to be doc dot h that will come first?
Like I'm copying doc.h to main.h because this is the first
You are copying doc dot h or you are copying main dot h to doc dot
I'm cop
h
I want to copy main.h to
to
doc.h.
doc dot h, yeah.
Mm-hmm.
So shouldn't
Franklin,
dog.h come first?
Franklin,
No, it should be main.h that should come first.
All right.
Yeah, the
left
destination
to,
is one that will come last.
left to me alone.
You
This
guys use
code is
your
like,
mouse and copy
I'm going to use what?
your mouse to copy it.
Exactly. Just VI into the uh, uh,
You don't overwrite my dog. Oh.
My brother, Franklin is
You
going to
don't
be
overwrite,
into things. He's going to hack
Franklin,
things.
Franklin. Just
you don't
VI into
overwrite
this.
my dog.
VI into it. Copy from there. Come to the dog.h. Just describe it. Additional prototype underneath there. Paste it there. Boom. Void
You
int
don't,
underscore dog. Every other thing. What are they?
No, like
don't
for real,
worry.
what you are trying to do, what you are trying to do should actually be feasible. We just didn't get it.
Mm.
Bros, if you person they play
Franklin,
black, person
do
is no
things the
respect of person.
hard way.
ALX, do things the hard
Do
way.
things the hard way. You are doing
Do
hard
difficult
things.
things.
Yes.
By now you don't finish your input,
You know,
whatever, void int dog,
on
print
the
dog,
norms,
whatever.
that stuff that we spent over 5 minutes on the norms, like if it's just like any other
one,
regular
if,
person,
one
we
second.
just like go and copy it and then paste it.
simple. You guys want to be too
But then
professional.
you know
But
the
we are
what's it
not
called
regular
there is
people now.
that yeah the
Challenge.
what's the catch there is that when you have like very large programs like that, what we
Mm-hmm.
are trying to learn actually is what will be better to like do what we want to do. But we are
Bros,
just seeing it. We are just seeing it
when we
as
reach that junction, we get large things. We
you know
will
how to
come.
cross the bridge, right?
My
When we get
brother,
there,
you
we
go
will come.
fall enter water.
Eh,
We go swim, okay? You know what tell them? Once we enter this journey, we go swim to the end.
no,
Okay.
so, someone should now make this kind of trial and error. Should make it on like maybe like 2,000 lines of code.
I won't take up yam now.
I want the copy back.
Hmm. When you for buy a man say, if you try this approach, it backfire. You don't jump out for you that too. But give
If
a try.
not me that night I will just carry my bag, come on, go my house. I don't close for the day with that.